Well, kids, today, it honestly is a very important lesson. Finally, we get to the day where we discuss why. Why really do we factor? Why do we just spend the last 2+ weeks talking about all these different ways to factor a problem? That is to change it to multiplication. And, well, we're going to find out today. Now, what you're going to see here, it's not the first time you've seen it. You should have dabbled with this in algebra. But to be honest, this is a major concept in Algebra 2. It's major. And you got to get this. Yeah, we're going to talk about it today. We're going to talk about it for a lot of days. But, the first day can be maybe the most important. So I hope that you're interested. I hope you're eager. And let's get this right. Let's figure out why we factor. Now, the short answer is so we can solve an equation. Oh, yeah, isn't that always the answer for algebra? Well, it's often the answer, but the truth is it's so we can solve a special kind of equation. Quite frankly, a quadratic equation. Now, that sounds pretty fancy, but a quadratic equation is an equation that at some point ends up with an x squared. Hey, we graphed those kind of equations at the beginning of this chapter. We graphed y equals x squared. We will be going back to that idea soon, but for now, we're just talking about equations. We're just talking about trying to solve a good old equation for like number answers. So, ready? Got 3 questions to kind of consider. Number 1, if A times B times C is going to equal 0, kind of a strange equation, but basically we're multiplying ABC and the whole equation is supposed to equal 0. What's got to be true about A or B or C? Come on, what's got to be true? That's right, at least one of them, at least either A or B or C, has to equal 0, right? If I'm going to multiply stuff together and come out with the number 0, then at least one of those things I multiply has to equal 0. Now, could it be all 3 of them? Sure. Could it be 2 of them or 1 of them? Yeah, at least one of them has to equal 0. Okay, well, that seems pretty simple. So how can I translate that to this statement? Well, do you see I kind of have like 3 things. I got an x minus 3, and I've got a 2x plus 5. Wait, they're equal to 0. So what's got to be true about these 3 things? That's right, at least one of them has to equal 0. So maybe x equals 0. Oh, that kind of sounds like an answer, like x equals 0. How about this? X minus 3 has to equal 0. Oh, wait, I have to kind of like think about that. I have to kind of solve it. If I solve it, I would just add 3 to both sides, or better yet, I would just know that x equals 3. That kind of sounds like another answer. Yeah, in fact, at this point, I have 2 answers. But what's got to be true, or what could be true about 2x plus 5? That's right, it could equal 0. Now, if 2x plus 5 could equal 0, then I got to solve it. Yeah, and this one, maybe you actually want to subtract 5 and divide by 2. I end up with like a little fraction or a decimal. No big deal. X equals 5 halves. Excuse me, negative 5 halves. Well, guess what? You just solved an equation. But there was something special about that equation. That is the original equation. It was factored. Factored means that it's multiplication. And so if I see something that is equal to 0, but it's not multiplication, that's right, I need to turn it into multiplication. In other words, I need to factor it. Wait, this is a kind of trinomial that we have been factoring a bunch in the last part of the chapter. 2 numbers that multiply to be negative 14 and add to be negative 5. Wait a minute. Think. Negative 7 and plus 2. Did you hear that crash sound? That's my cat again. Just messing around with stuff in the workshop, and suddenly something comes crashing down. All right, so I factored it. And look, I have something that can equal 0. X minus 7. Wait, if x minus 7 has to equal 0, that means that x equals 7. You just solved that. At least you solved for one of the answers to this equation. How about x plus 2? Wait, can I just kind of do this in my head and say that x equals negative 2? Yeah, you can. You just solved the equation. In other words, you solved this original equation, but you did it using factoring. So let's make a couple observations here, because these are the kind of equations that we're going to solve. We're going to solve equations that are equal to 0. In fact, they have to equal 0 for this to work. Then you're going to factor. You're going to factor because you want to turn it into multiplication. And simply then determine the x that's going to make each group, each part, each factor equal 0. That means you could have many answers. Okay, now, ready? We're going to solve quadratic equations. Quadratic equations, they're equations that have an x squared in them. They also have other stuff in them. And so we want to recognize that these equations like to equal 0. Okay, now if the equation's got to equal 0, that means I probably need to move some things around. Like kind of move x squared back over on this side and, like subtract 5x over here. Basically, I rearrange the equation to be x squared minus 5x plus 6. But now it's equal to 0. And it looks like a trinomial. It looks like something I can factor. Two numbers that multiply to be 6, but add to be negative 5. Okay, very important that you write these correctly as x minus 3 and x minus 2. Now, what I can do is I can solve x minus 3. What do you mean solve? I mean, what makes x minus 3 equal 0? Yeah, I mean, if you're ready just to say x equals 3, great. Okay, you just solve for one of the solutions. How about this one here? Again, can I just kind of look at this and say x equals 2? Most definitely. In fact, when you're ready, that's what we're going to do. Now, I'm not going to do this for every problem, but just remember what just happened here. We just solved this equation. That means if I plug in 3, now if I plug in 3, I'd have to be plugging in 3 for both the x's. Okay, so I found 3. That means if I plug that in, I get 15, right? Minus 9. Oh my gosh, that does equal 6. And then what else could I plug in? I could plug in 2. Yeah, my other answer was 2. And if I plug that in, I got to plug it in for both x's. It's going to give me 10. It's going to give me 4 minus 4. And by golly, that does equal 6. So the method that we're going over here 100% works. We just got to be ready to use it. Okay, it's a method to solve a quadratic equation. What's going on? Why are we slowing down here? Well, I know this one's a little harder to do, right? It's got a coefficient. Now, when you have a coefficient, maybe you have to use the British method. Or maybe the numbers aren't so bad that we can just do a little simple guess and check. Okay, listen, the only numbers that work for 5x squared are 5x and x. And the only numbers that work for 3 are 3 and 1. Now, they're not going to add to be negative 8. That's not the way it works. They're supposed to check to be negative 8. That means I need to carefully place minus 3 and minus 1 in here. Now, did I get it right? Okay, did I get it right? Well, that depends on if when I check my answer that these outer and inner numbers are going to give me negative 8x. And if you're doing a little mental math here, you get negative 5x out of that. You get negative 3x out of that. And those check to be negative 8. Now, that's what we were doing in the last part of the chapter. Now what are we doing? Yeah, we're solving it equal to 0. So I got an extra step. I have to actually take 5x minus 3 and set it equal to 0. And yeah, I mean, unless you can do this in your head, which I know some of you can, you got to kind of do some algebra. Like add 3 and divide by 5. Okay, it's not like awful. So we get 3/5. This one over here, you probably can do that, should be able to do that in your head. That's just going to come out to be x equals 1. Either way, I have 2 answers. Both of them I found using factoring. And of course, the equation equal to 0 to boot. Try one. You should be ready to try one on your own. This is a trinomial. That means it can be factored. It's equal to 0. Be careful here. Numbers that multiply to be -3 but add to be 2. Okay, so it's going to be 3 and 1, but you want it to be a +3, yet a -1. And then when you write out your answers, yeah, your answer kind of becomes like the opposite of what you wrote down. Yeah, the opposite of what you wrote down. But I end up with a -3 and a +1 for my final answers. What's going on with this fourth one here? Yeah, it's not equal to 0. Okay, now if the equation's not equal to 0, I got to move some things around. Most of the time, you move things so that you end up with a +x squared. So, I got a +x squared already, but this changes to a 4x and to a -12. Yeah, that looks a little bit more like a trinomial that I can factor. Yeah, numbers that multiply to be -12 but add to be +4. Now be careful, you should not be using 4 and 3, but you should be using 6 and 2, specifically -2. Remember, when you write your answer, you're actually writing the number that's going to make this equal 0. You're writing the number that's going to make this entire group equal 0. That's why I actually write x equals +2. Well, we're underway. We're solving a quadratic equation. Now, what I showed you is definitely true for the majority of quadratic equations. That is, they got equal 0, we're going to factor them, and we're going to set groups equal to 0. But I want to show you here on the first day that some equations that are quadratic, now quadratic just means that it's got an x squared. So some equations that are quadratic can actually be solved without using complete factoring. I just want you to see this on the first day to kind of keep your mind open. You look at an equation like this and you should feel like that there's simply one x term. And if there's one x term, I can kind of go back to standard type algebra where I end up, well, really just isolating, adding 50 and dividing by 2. Now, it turns out that when I do that I have this extra step. Because if x squared equals 25, then I have to take the square root of both sides to end up getting my actual x. Now, when you take the square root of something, specifically when you take the square root of both sides, you always get plus or minus. You basically get like two answers, like x equals 5 and then x equals -5. But what happened here is I used more like a square root method because I could. Because there was one x in one place, and I simply... So we see here again an opportunity to use a square root. Now, how do we know that? Yes, it's because there's a square, but a lot of equations have squares. I have to admit it's also because there is just a square and not any other type of x. And some of it's also anticipating that you're going to be able to take the square root of this quantity. But what we got to be careful is that we don't do it in the wrong order. You see, some students want to take the square root of sort of everything in this equation, and you can't do that. You can't take the square root of the x minus 2 squared and the plus 16 at the same time. Instead, we have to get ourselves thinking a little bit more like doing an isolation of the square. And an isolation of the square means that I actually first have to move the 16. Now, of course, moving it means you have to subtract it to the other side, and when you subtract it to the other side, it really turns into -16. Now, here's where you want to recognize that it's time to take the square root. And again, the square root's going to cancel with the square, but now you're going to take the square root of both sides. You see, you can only ever do an operation to both sides, and so is this going to cancel? Yes, we've been waiting for it to cancel. But what do we have over on the right side of the equation? We have the square root of a negative number. Yeah, where have we heard that before? We've heard that in imaginary land. And so we know that the square root of a negative number is going to produce an imaginary number because the negative is going to, it's going to turn into the letter I, and that allows you to take the square root of 16. Yes, the square root of 16 is 4, but really what we get here is 4i. Well, actually, we get plus or minus 4i, because remember, you always get plus or minus when you take the square root of both sides. So am I done yet? Well, not really, because I'm trying to solve for x. So I got one more little step. I got to add 2 to both sides. And when you do that, you end up with, finally, x equaling, right, 2 plus or minus 4i. And we'll write the answer in that form. That's called a conjugate. I'm going to be showing you a way that we can use like a variation of the factoring strategy from up above. You say, well, what do you mean? Well, what I mean is instead of subtracting 4 from both sides and making this equal 0, which we could do that, I'm going to recognize that I can actually factor this, since it's a PST, into x plus 3, the quantity squared. Now, here's the deal. Because I can do this, because I can factor it into a nice little perfect square, now I have 1x in one place. And I can actually take the square root of both sides, kind of like a square root method, to be able to solve for x. Okay, what happens here is I do end up subtracting 3 from two numbers. If I subtract 3 from positive 2, I get negative 1. But if I subtract from negative 2, I get negative 4. That was like a square root method. Okay, you say, well, what if I had used the method you were showing me up above? Well, if I need to erase this, you can see. If I had used the method that I was showing you up above, then I would have made this equal 0. Let's tell you what, let's change the color. I would have made this equal 0, and then I would have been messing around with x squared plus 6x plus 5. Now it's equal to 0, which is nice because then I can factor it. Look what's going to happen here. I factor this into x plus 5, x plus 1. Yep, you got it. I end up with 2 answers, and they're the same answers. Wait a minute. Why didn't anybody say anything? Negative 4? Yeah. What? Negative 5. You probably did say something. You just... obviously, it's a video. Okay, yeah. Negative 2 minus 3. That's negative 5. And thank goodness, because that's going to be one of the answers that I get from my first group. And then my other answer is going to be negative 1. Now, there's a lot that was in that problem. To be 100% honest, we're going to be spending more time with that. But the whole point here is that there can be different methods for solving quadratic equations. Okay? And what I want you to do is I want you to try a method, probably the method that sort of seems most comfortable to you as you guys try numbers 4 and 5 kind of like on your own. Okay, so try 4 and 5 on your own. How you doing? Okay, I know maybe you're like, nah, I don't know what to do. Listen, single x in one place, that means that I can do like traditional algebra. Traditional algebra would be that I isolate, and since I'm isolating, I'm going to have to add 49. First, take the square root of both sides, get rid of that x, or get rid of that square. Now you do get plus or minus 7. And then when you subtract 6, let's do this carefully. Positive 7 subtract 6 is 1. Negative 7 subtract 6 is negative 13. Okay, probably the best way to go about that problem. honestly, the truth with this problem is there's two ways to do it. Which way do you want to do it first? You want to set it equal to 0? All right. That's kind of what we did on the front of the paper for a majority of the problems. If I set it equal to 0, I'm hopefully getting myself ready for some factoring. Now, we're talking about like kind of just good old factoring, where you're trying to find numbers that multiply to be -9, but add to be add to be -8. Yeah, x minus 9, x plus 1. Okay, and that produces two answers. 100% right, and honestly the method that most of you are probably going to use. But there is another way, and the other way is to recognize that I do have like a perfect square trinomial. It's called a PST. If you notice this, then you can actually 100% rewrite the problem as x squared, or as x minus 4 squared equals 25. Okay, and you're using a little bit more of like a square root method here. You're basically taking the square root of both sides. You're getting plus or minus 5. And when you add 4 to that, see if we can do this, if I can do this correctly this time. Yeah, plus 5 plus 4 is going to be 9, and minus 5 plus 4, or negative 5 plus 4, is going to be -1. Same two answers. If you can find a PST, if you can find a perfect square trinomial within the equation, then you can factor that PST and use a little bit more of like a square root method, just like we did in blue. I say if, okay, and the equation actually doesn't have to equal 0 when those things happen. Now, section 3, we're going to dabble with a graph. I told you that we would eventually really hit that, but same thing, we're going to kind of dabble with it. We're actually going to do that in tomorrow's video. So draw a line. Well, the line's already drawn, but go ahead and switch gears to the homework. There's a homework half sheet that also goes with today's lesson. And then again, tomorrow we'll hop in here and we'll look at this graphing problem.